All right, how's it going, everybody? Big crowd.
Hello.
All right, so I'm Everton. I'm a senior Web3 specialist, solution architect. With me, Simon Goldberg.
I'm a Web3 specialist solutions architect based out of Atlanta, Georgia. Thank you all for coming today.
All right, and today we're going to talk about this very interesting topic of blockchain datasets and why we're doing with having them publicly available, right? So as far as agenda, we're going to talk about Amazon Managed Blockchain Query and the AWS Public Blockchain datasets. Then we're going to go over some of the dataset schema examples, and then talk about one of the partners that we have, and also we have a little demo that we prepared for you about text to SQL queries using Amazon Athena. Also some deeper dive on AMB query overview, and then that's it. All right, so Amazon Managed Blockchain Query is a fully managed service that we created to help with, to go around all the complexities of indexing your blockchain data, right? So AMB Query provides very simple APIs for you to query directly from your applications, set up structured data from your blockchain, workloads. So we take care of all the indexing, the loading, and we provide very low latency access to those informations. As far as chain support, we have Bitcoin and Ethereum available for those. So you can query some of the hard queries to make. I would say like past balances, something that it will require you to have an archive node that comes with all the complexities for it on Ethereum. And for Bitcoin, you can query all the native Bitcoin balances, transaction histories, and more. All right, I'm going to take over.
The AWS Public Blockchain datasets were released as an open source project in 2022 with support for the Bitcoin and Ethereum blockchains. AWS has built up an ETL process internally to perform a transformation on data as we perform RPC requests on both the Bitcoin and Ethereum blockchains. And once it goes through the transformation process, we persist it into a public S3 bucket called AWS Public Blockchain. Let's take a look at a couple of schemas that represent what the data sets actually look like and the insights that can be gained from them. For the first schema, we'll look at the one for Ethereum, and it has 6 different tables, one for blocks, one for transactions, one for logs, token transfers, traces, and contracts. It's quite an extensive set of data sets just for Ethereum itself. When it comes to Bitcoin, we have just 2 separate tables. The first one is blocks, representing the first Bitcoin block that was mined in 2009 up until the most recent block head, along with every single transaction in the data set. We have found that these data sets are very useful for performing SQL queries, whether them being basic or advanced. For example, you can determine what the largest Bitcoin transaction was of all time, or you could also create a type of heat graph to show the flow of money between different accounts, which is pretty interesting. And now I'll throw it back to Everton so we can go over how we've actually expanded on this initial set of chain support for just Bitcoin and Ethereum and how we are going above and beyond on that.
Thank you, Simon. All right, so we've been asked by customers many times, so hey, are you folks going beyond Bitcoin and Ethereum? We heard that from many, and we tried to address that in the best possible way. And we are happy to announce that this week we just made available 5 new data sets. Those are provided by our indexing partners, SonarX at the bottom. And so we effectively have onboarded Aptos, Arbitrum, Base, Provenance, and XRPL. And the way that it works is actually pretty simple. So all the data is loaded onto our public S3 buckets every day. And folks can, without even free of cost, folks can even download those data sets. Or they could plug to some of the AWS services, such as Redshift, SageMaker, or Amazon Athena. So you can start querying right away. So the way that it works is that you can create Amazon Athena data catalog pointing to to those S3 buckets, or you can create a glue crawler that can periodically take a look at sample files of these data sets, and then it creates a schema so you can effectively query that from Athena. So we hope that we're lowering the cost of indexing for indexing data for folks that are researching, they're experimenting with data. Moreover, we have folks on the financial services that sometimes they have a very high requirement for AppSec, right? So they can now start working with public data without having to go through all the hurdles. So they can first learn about the data, and then that can effectively help them with their procurement process and with the IT requirements. So we see these as a way to really lower all the burdens that some customers told us about. Right, so those are the new ones. If folks want to have, we know that 5 blockchains plus the 2 that we had before, that does not cover the whole universe, right? So still on that partner, they have offerings for over 70 blockchains, and they have their proprietary data quality framework, and they are, they have the enterprise-ready infrastructure about scalability and such. All right, so we prepared a demo. Want to take over, Simon?
Yes, please.
Yeah.
Yeah, we have a pretty interesting demo to show you all today. We essentially built on top of the AWS Public Blockchain datasets and added an additional component. We all know that generative AI is quite a hot topic right now, and we were really thinking about a genuinely useful solution combining Gen AI along with Web3 data. And with that, we can take a look at the demo. We prepared a Bedrock agent that does text to SQL, and you can ask questions in plain English where the agent understands the user's intent, generates the SQL query, calls an associated Lambda function, executes the generated query on Amazon Athena, and then the response gets returned back to the agent. And in the case of there being an error, the system automatically analyzes the error message and tries to formulate a new query, which is quite an effective way to improve the overall posture of the solution. But yeah, I'll let this play real quick, and we'll look at how this works. As you can see, you can enter in a natural language question, such as, what was the largest Bitcoin transaction in the last 24 hours? And you get a nice response back in an easy-to-read format. You could also ask how many Ethereum contracts were created in the last week, or how many stablecoin transfers that there were yesterday. You may even be curious about what the largest stablecoin transfer this month was. And you can even ask questions such as, what was the most expensive Ethereum transaction this year? One of my favorite questions to ask is, what are the most popular smart contracts of the last 24 hours, or the last hour, for instance? And that really shows you where all the activity is happening in the greater DeFi ecosystem, and I think that is pretty interesting. We'll now go over a quick architecture diagram of this solution, just so you can learn about the Bedrock agent pattern and how we integrated into this Lambda function that can execute a query on Amazon Athena. We start with the user who types in a prompt such as, what was the largest Bitcoin transaction of all time? Or how much Bitcoin trading volume has there been over the last month or year? The Bedrock agent in this example was utilizing the Claude Anthropic Haiku model due to us not having that much context in the prompts that are baked into the agent itself. Based on the user's initial prompt, the Claude Haiku model really understands your intent. For example, if I ask what the most popular smart contract today was, the model is inherently aware that Ethereum has smart contract support, but Bitcoin does not. And the agent knows to craft a query for the Ethereum dataset rather than Bitcoin, which I thought was pretty cool. Once this query gets created, it gets passed to an action group, and an action group is essentially this middleware between the agent itself and some type of compute functionality. And in this case, our action group had a very simple description. You will take a SQL query and return a response back to the user. It took a single input, the query, and returned back the raw data response. Once the action group goes to the Lambda, the generated query gets passed in, and then the Lambda function executes it on Amazon Athena, which gets run on the AWS Public Blockchain datasets. When this solution was first built out, we only supported the Bitcoin and Ethereum blockchains, but now that we have added 5 additional chains, it can be further extended to allow for text-to-SQL queries on other chains such as Base and XRPL. And going back to the error handling technique, like sometimes the agent can make a mistake due to the non-deterministic behavior of it, and a SQL query might not have valid syntax, but by simply telling the agent and its associated instruction to analyze the error message to generate a new query, it gracefully recovered from multiple different errors, which was really cool to see. We'll now talk about some synergies between the AWS Public Blockchain datasets and AMB Query.
Yes, absolutely. Thanks, Simon, for the demo and for all the information about it. Gracefully recovering from non-deterministic behavior is something really useful, right? So thanks for showing and detailing that. All right, so there is certainly some overlap between what you can have from AMB Query and what you can have from AWS Public Blockchain datasets. However, the differences are actually big. So AMB Query allows you to make very low latency requests to our service. Then you have very structured information already, including past balances. So you would not find that on AWS Public Blockchain, though, on the data sets, though. You have all the transfers, you have block information, transaction information, but not the actual balances, right? So there's definitely some synergy, or I can definitely see some use cases where you could have, a merger of both. So if based on so many other analogies, you can properly say that AWS provides you with a lot of options, and this is one of those, right? So I'm really curious to hear more from your use cases and to see exactly what are your folks planning to build.
And to go over one concrete example from the research we've done comparing the public blockchain datasets and AMB Query, we found that querying a single Bitcoin balance via Amazon Athena took approximately 75 seconds to complete due to having to scan 1.15 terabytes of data, which is quite a lot of data. And when you look at Athena's pricing and how cost works with that service, you have to pay around $5 per terabyte of data scanned. So if you want to get the balance of a single Bitcoin wallet, you have to wait 75 seconds. You're paying about $6, and it's not exactly an ideal experience. And I really believe AMB Query fills in this gap by offering millisecond latency and a fixed cost of around $6 to $7 per million requests. Where if you do the math, it's about 1 million times cheaper, which is not so bad.
Yeah, absolutely. All right, and I'm sure that you folks have heard or seen the recent launch about S3 tables, right? And some comments about this is we store the files currently in Parquet format on S3. So that allows us to read those files quickly. But we're looking to explore other avenues for that, and whatever makes the million times of difference, right? To shorten that, to shorten this gap, we're pretty much up for that. All right, so we have some QR codes for you folks about references. We have the AWS Public Blockchain Data website. It is a landing page with all the S3 URIs so you folks can explore. And we have this amazing guide about analyzing blockchain data with natural language using Bedrock.
And thank you all for coming once again. And as we look forward, we really hope to see how these new chains do in our open data sets. And we hope to expand to more chains in the inevitable future.
Right.
And with that, I would like to say thank you once again for joining our session, and have a great rest of your day and a happy reInvent. And an even happier holidays, of course.
Thank you. Thank you.